Unveiling the Wonders, Interesting Facts about Galileo Galilei. Born in the picturesque city of Pisa, Italy, in 1564, Galileo Galilei's contributions have crowned him as the father of modern observational astronomy. His early life in this culturally rich environment set the stage for a legacy that would forever alter the way we perceive the cosmos. Galileo broke new ground in 1609 by being the first to point a telescope toward the heavens. His enhancements to the telescope's design opened up the universe, allowing him to study celestial bodies with unprecedented clarity. This marked a pivotal moment in astronomy, bridging the gap between Earth and sky. In 1610, Galileo's keen observations led to the discovery of Jupiter's four largest moons, Io, Europa, Ganymede, and Callisto. These celestial bodies, now known as the Galilean moons, provided concrete evidence that not everything in the cosmos orbited the Earth, challenging centuries-old beliefs. Through his telescopic explorations, Galileo became a staunch supporter of the Copernican theory, which posited that the Earth and other planets revolve around the Sun. This heliocentric view was radical, directly contradicting the prevailing geocentric model that placed Earth at the universe's center. Despite the brilliance of his discoveries, Galileo's advocacy for heliocentrism attracted the ire of the Catholic Church. In 1616, the Church cautioned him against holding or defending the Copernican theory, setting the stage for a conflict that would define both his career and the intersection of science and faith. Galileo's investigation into the pendulum uncovered a remarkable principle that would echo through the halls of science: the period of a pendulum's swing is constant, irrespective of its arc. This discovery not only demystified the workings of pendulums, but also provided a new tool for measuring time more accurately. His ingenuity extended beyond the celestial, as he refined the military compass, a critical instrument for navigation and warfare. Galileo's enhancements made it more versatile, aiding soldiers and sailors in their quests across unknown lands and seas. This contribution marked a significant advancement in the technology of exploration and military strategy. Moreover, Galileo's curiosity led him to discover sunspots, dark patches on the Sun that seemed to challenge the unblemished celestial sphere Aristotle had envisioned. This observation further dismantled the Aristotelian view of the heavens, suggesting a dynamic and ever-changing universe contrary to the accepted wisdom of the time. Facing the might of the Catholic Church, Galileo stood firm on his support for the heliocentric model, which placed the Sun at the center of the universe. This bold stance led to a trial by the Inquisition, where he was found vehemently suspect of heresy. The trial was a pivotal moment, highlighting the conflict between emerging scientific truths and established doctrine. Despite the Inquisition's verdict, Galileo's spirit remained unbroken under house arrest. In these quiet years, his pen continued to dance across the pages, contributing further to the world of science. His resilience ensured that his ideas would outlive the constraints placed upon him, sowing the seeds for future generations to harvest. Galileo Galilei's Dialogues Concerning the Two Chief World Systems is a pivotal work that contrasts the Copernican system, which places the Sun at the center of the universe, with the traditional Earth-centric Ptolemaic model. Through this comparative study, Galileo provided compelling arguments in favor of heliocentrism, challenging centuries of astronomical thought. His investigations into the laws of motion and universal gravitation laid the groundwork for future scientists, notably Isaac Newton. Galileo's ability to conceptualize and articulate the principles governing the motion of objects was revolutionary, offering a new lens through which to understand the dynamics of the universe. Despite facing opposition from the Church, Galileo's commitment to scientific exploration remained unwavering. His work, Two New Sciences, delved into the realms of mechanics and motion, establishing foundational concepts that would inform the development of classical mechanics. This perseverance under scrutiny underscores his dedication to advancing human knowledge. Through his telescopic observations, Galileo revealed the Milky Way as a dense collection of stars, challenging the prevailing belief in its nebulous nature. This discovery not only expanded our understanding of the galaxy, but also demonstrated the power of the telescope as a tool for uncovering the mysteries of the cosmos. Galileo was among the first to observe lunar libration, noting the moon's slight oscillation that reveals more of its surface over time. This observation, along with his studies of the moon's uneven surface, further dismantled the Aristotelian concept of perfect celestial bodies, marking a significant advancement in astronomical science. Galileo Galilei's staunch advocacy for experimentation and empirical evidence marked a monumental shift in scientific inquiry. His method of observing, hypothesizing, experimenting, and concluding laid the groundwork for the scientific method. This approach challenged centuries of speculative thinking and encouraged a more rigorous, observational study of the natural world. The discovery of the phases of Venus by Galileo provided a significant blow to the geocentric model of the universe, which posited Earth at its center. This observation offered tangible support for the heliocentric model, suggesting that planets, including Earth, revolve around the Sun. It was a pivotal piece of evidence that challenged traditional astronomical beliefs. Galileo's contributions to physics and motion are unparalleled. His work directly influenced the development of classical mechanics, a branch of physics concerned with the motion of bodies under the action of forces. His insights into inertia and the laws of motion paved the way for Newton's later work on universal gravitation. The Catholic Church's posthumous pardon of Galileo in 1992, over 3 centuries after his trial, reflects a profound reconciliation with his scientific findings. This act acknowledged the unjust condemnation he faced for advocating heliocentrism, a theory that is now a foundational concept in astronomy. Galileo's letter to the Grand Duchess Christina argued eloquently for the coexistence of science and religion. He believed that the two realms addressed different questions and that scripture should not be used to argue against observable facts about the natural world. This plea for harmony between faith and reason remains relevant today. The Galileo affair marks a critical juncture in the annals of scientific thought, emblematic of the clash between rigid ecclesiastical doctrines and the burgeoning spirit of inquiry and evidence-based conclusions. Galileo's steadfast support for heliocentrism, positioning the Sun at the solar system's heart, directly contradicted the Church's geocentric stance, precipitating a confrontation that would resonate through history. This moment underscored the tension between science and religion, a narrative of conflict and conciliation that continues to shape our understanding of the universe and our place within it. In the realm of hydrostatics, Galileo's insights into buoyancy were groundbreaking. His early work laid the foundations for fluid dynamics, exploring how objects behave in fluid environments and offering a mathematical framework that would inform centuries of scientific inquiry. These explorations further exemplified his pioneering approach to combining empirical evidence with mathematical rigor, a methodology that would become a hallmark of the scientific method. Galileo's concept of inertia, a precursor to Newton's first law of motion, introduced a fundamental principle of physics, that an object in motion remains in motion unless acted upon by an external force. This idea was revolutionary, challenging the Aristotelian physics that had dominated scientific thought for centuries. Galileo's insights into motion and inertia not only paved the way for Newtonian mechanics, but also fundamentally altered our understanding of the natural world. At the heart of Galileo's scientific philosophy was the conviction that the laws of nature are mathematical. He was among the first to articulate the idea that the universe is written in the language of mathematics, an assertion that has since become a cornerstone of modern physics. This perspective underscored his belief in a harmonious universe governed by discoverable and predictable principles, shaping the course of scientific inquiry for generations to come. Galileo Galilei was a pioneer in the systematic recording of observations, merging experiments with mathematics to explore the natural world. This innovative approach enabled him to lay the foundational stones of modern physics and astronomy, demonstrating that the laws governing the universe could be deciphered through careful measurement and mathematical analysis. His dispute with Aristotle's followers highlighted Galileo's commitment to empirical evidence over philosophical speculation. By meticulously documenting the behavior of falling bodies, Galileo challenged long-held beliefs with hard data, paving the way for the empirical method that has become a cornerstone of scientific inquiry. Galileo's final resting place is in the Basilica of Santa Croce in Florence, Italy. This burial site honors his monumental contributions to science and his enduring legacy in the history of human thought. It serves as a pilgrimage site for those who wish to pay homage to the man who changed how we perceive the universe. The Galileo spacecraft, named in his honor, was launched by NASA in 1989 to study Jupiter and its moons. This mission symbolizes Galileo's lasting impact on astronomy, extending his legacy of exploration to the far reaches of our solar system and providing invaluable data about Jupiter's complex environment. An accomplished lutenist, Galileo's musical talents reflect the Renaissance man's wide range of interests and abilities. His father, a renowned lute player and music theorist, undoubtedly influenced Galileo's appreciation for the arts, illustrating the interconnectedness of science and art in understanding the natural world. Galileo Galilei's academic journey began not with stars, but with the human body. Enrolling at the University of Pisa to study medicine, his curiosity was vast. However, it wasn't long before the allure of mathematics and physics captivated him, redirecting his path towards the mysteries of the universe. In his personal life, Galileo found solace and support in his daughter, Sister Maria Celeste. Their letters, filled with affection and intellect, offer a window into Galileo's world beyond his scientific endeavors. This correspondence highlights the depth of their relationship, showcasing a man who valued family and intellectual companionship. Galileo's exploration into the realms of velocity and speed marked a significant advancement in physics. He distinguished between the two, laying foundational principles that would later influence the development of classical mechanics. His work in this area underscored his ability to dissect complex concepts into understandable theories. However, Galileo's advocacy for the Copernican system, as presented in his Dialogue on the Two Major World Systems, was met with fierce opposition. The Catholic Church placed the work on the Index of Forbidden Books, a stark reminder of the tensions between scientific inquiry and religious doctrine during his time. Despite facing severe adversity, including blindness in his final years, Galileo's resolve to understand the cosmos never waned. He continued to theorize and dictate his findings, a testament to his unwavering dedication to science. His ability to contribute meaningfully to the field, even in the face of personal hardship, remains a profound legacy. Galileo Galilei's innovative use of the telescope marked a turning point in the field of astronomy. His pioneering observations brought the cosmos closer to humanity, unveiling the universe's complexities in unprecedented detail. This groundbreaking approach not only revolutionized the study of celestial bodies but also fundamentally altered our understanding of the universe. As a professor of mathematics at the University of Padua, Galileo's teachings went beyond the confines of traditional academia. His tenure from 1592 to 1610 was characterized by a relentless pursuit of knowledge, inspiring a generation of thinkers to explore the mysteries of the natural world through a lens of empirical evidence and mathematical precision. Galileo's legacy is deeply embedded in the fabric of modern astronomy. His observations and theories have laid the groundwork for contemporary astronomical methods, enabling scientists to probe deeper into the cosmos. His work serves as a foundation upon which the edifice of observational astronomy is built, guiding the explorations of the heavens to this day. The term Galilean transformation honors his contributions to physics, encapsulating the essence of reference frames in motion. This concept is a testament to Galileo's profound impact on our understanding of the physical laws governing the universe. It highlights his role in shaping the principles that define motion and transformation across different perspectives. In recognition of his monumental contributions to science, the unit of measure for acceleration, the Gal, bears Galileo's name. This honor reflects the enduring influence of his work on the field of physics, immortalizing his legacy in the very language of the science he helped to forge.